feature evidence.
Good. Create shader as well. We'll not make that static and we'll make it a member shader like that. And this is probably a bit big. Let me make it a bit smaller. Hopefully you guys can still see. Compile shader becomes a member as well. Okay, that looks pretty good. So let's start making these actual functions. So we have, I might make them up here, I guess. Unsigned int create. Hey, what's up, guys? Hey, what's up, guys? My name is Cherno and welcome back to my OpenGL series. So today we're going to have a nice chill episode in which we just talk about how we're going to abstract some of the code that we've actually written in the past episodes out into some classes so that we can use it more easily as we start to get into more complicated OpenGL stuff, which is obviously where the series is headed. So I did mention a few times throughout creating this series that I really don't want to make this a game engine series. I don't want to make it like a, hey, we're going to build some kind of OpenGL engine or like a rendering engine or anything like that. I don't really want to spend too much time moving code around and setting stuff up and making it absolutely bulletproof and absolutely perfect, because that's not the point of this series. This series is just me showing you how to use OpenGL. However, in the real world, in order to actually use OpenGL, you do need to perform some kind of abstraction of some sort, because otherwise you're just going to end up having a pile, just a messy pile of code that doesn't make much sense to you. It's going to be extremely verbose, and you're just gonna, it's gonna be difficult to debug. There's all sorts of issues, and it's gonna be extremely difficult for me to show you, for example, how to implement shadow mapping if I'm all doing it in one file with just raw OpenGL kind of code, because it's not gonna make much sense. So what I'm going to do over the next few episodes is start moving code out into classes and showing you how we can kind of, I guess, move common code around so that we can reuse it a lot of times, maybe parameterize it as well, and all that stuff. It's also a really good opportunity to show me a little bit, or for me to show you guys a little bit about how OpenGL can be abstracted and how it typically would be abstracted in a game engine, even though we're not going to go as deep into this as if I was actually writing a game engine potentially with multiple rendering APIs. It's going to be fairly brief and high level here, but still, it's a really good chance for me to just show you guys how you would typically go about abstracting OpenGL anyway. So out of what we've done so far, there are a few things that we need to actually move around. There's the vertex buffer setup, right? The index buffer setup, vertex arrays as well, and whether or not we even want to use them. I've said in the previous episode, I think, which was about vertex arrays, that we will be using them. So we need to set up some kind of abstraction for that. And then there's the whole shader situation. That's probably it. If you really think about what we've done so far, we haven't done textures yet, or anything like that, or frame buffers or anything like that. Obviously, it's not like we have a complete, every feature of OpenGL implemented in this main file. But it is getting a bit lengthy. I think it's about 200 lines of code. And it's getting a little bit hard to tell what's actually going on, and it's a little bit hard to read. But in terms of what I just listed out there, vertex buffer, index buffer, vertex array, and shader, that's pretty much all we have right now that we can abstract. However, there is one thing that needs to tie everything together, and that is traditionally known as a renderer. So we do need to create a renderer at some point as well. And the idea with a renderer is fairly simple. You basically give it a command, and it will render that thing for you. So in other words, I want to be able to say, hey renderer, can you please draw me this? And then the draw kind of function will potentially take in everything it needs to draw something, which traditionally would be like a vertex buffer, an index buffer, potentially any kind of textures, any render states, such as you do want blending on, should we be writing to the depth buffer, that kind of stuff. And then obviously, what did I say, vertex buffer, index buffer, like a materials, like a shader, maybe textures, stuff like that. And then all the render states, right? So that kind of concept of a renderer needs to also exist. And that's going to be extremely important for us to implement. So what we're going to do is today just focus on vertex buffers and index buffers, which should be very easy, especially because we've decided to use vertex arrays, so we don't have to worry about the layout of an actual vertex buffer when we write that vertex buffer class. We only care about the actual data, which is just a bunch of bytes, really easy to deal with at this point. And then the index buffer is basically the exact same thing. Literally, index buffer, vertex buffer, basically the same thing, as far as the abstraction and everything like that. And then in the next episode, we'll probably deal with vertex arrays, and then after that, probably shaders, and then after that, maybe the renderer. And then once we have all that kind of collection of classes set up, we'll be able to actually use them to do things in a relatively easy way that should look very simple in this application, file class thing that we have going on right now. So that's the plan. Let's dive in. Let's start abstracting this code. Okay, so first of all, if I just hit F5 so I can show you guys where we're at, of course, is where we left off in the other episode. We basically just created a vertex array and how to do this little animation of our rectangle color here. The main things that I'm going to be focusing on today is this vertex buffer, which is right over here. We'll just call it buffer, and that's just taking in these float positions, and that's pretty much it. And then of course the index buffer, which is this thing here. Now this kind of stuff, this vertex attribute stuff, which is the actual layout of our vertex buffer, that's going to be dealt with in the vertex array class and all that. And vertex array class will probably end up taking vertex buffer objects into it as well, because we typically tie vertex buffers with actual vertex arrays and their layouts and all that kind of stuff. And then after that, of course, we'll deal with shaders. Shaders are going to be a little bit more complicated because we need to actually deal with uniforms and all that. So that should be a fun episode. But anyway, today, nice and simple, vertex buffer and index buffer. How do we do that stuff? So first of all, if we scroll up to the very top, you'll see we have some stuff that's fairly common, right? Like this error checking is stuff that's kind of common to OpenGL right now. So what I'm going to do is under source over here, I'm going to right click, add new item. And I'm going to just add a header file, and I'm just going to call it renderer. Again, I don't really want to set this up like a game engine or anything, so I'm going not to try to create too many classes. So I'll keep this nice and simple, and I'll just put it into the renderer class, which will eventually contain our renderer as well. So I'm making a CPP file as well, because we need that. So we have a renderer CPP and a renderer.h. Okay, into the renderer.h, I'm actually going to put in this assert, which might not seem very intuitive, because assertions are typically used throughout our entire program, not just the renderer, but it's okay. In fact, I'm just going to copy and paste all of this kind of stuff, cut it, and then put it into renderer.h, which I just pinned accidentally. Whoops. Okay, cool. So now this is what we have. I'm going to include some stuff. Now we are obviously tying this with GL, so it's okay to just include glue over here in our renderer header file. And then what else do we need? IOStream potentially. We don't really need that stuff here. I'm not going to include IOStream. All we need is really just glue. Okay, cool. So now this stuff, what do we do with this stuff? Well, the first thing I'm going to do is get rid of static and then just make it an actual declaration rather than a definition, because we're going to move that definition into the actual CPP file. So I'll get rid of static for GL log call as well, add a semicolon. In fact, let's just copy both of these. We're going to put it into the CPP file. In there, I'll include renderer.h and paste in this stuff. And then back over here, I'm going to just get rid of the bodies of these two functions. Like that, and there we go. Okay, looks pretty simple. And then in renderer CPP, we've got that stuff. Let's get rid of these semicolons. Now here we will actually need to include cout, so let's include IOStream, and that looks pretty good to me. Okay, so we've moved out the kind of common stuff, and we can just include renderer in all of our classes if we really need to get access to this kind of GL call macro and everything that it does, as well as assert. Cool. Okay, so back in application, let's take a look at what we actually need to move out here. So straight away you can see GL call, of course, is giving us an error because we now need to include renderer because we need the macro. And then let's scroll down and take a look at this buffer stuff. So this is the actual code that we need, and that really is like all of it. I mean, this bind buffer will need to kind of be reused in some kind of bind method, because we will have to rebind kind of different buffers as we go along. But the actual creation is just gen buffers and then setting the data. That's it. Really easy, really simple. So under source, I'm going to right click, add new item. It's going to be a header file, and we're going to call this vertex buffer.h. I'm going to do the same thing for the CPP file. Vertex buffer.cpp. Vertex buffer CPP is going to include vertex buffer.h. I'm also going to right click on vertex buffer or vertex buffer and rename it to vertex buffer, because I did misspell that. Okay, cool. Now if I go back to my header file, I'm going to type in class vertex buffer. It's going to have one private member just for now called unsigned int m renderer id. Now I did say just for now, but it will have that forever. What I meant is we're just going to add just one member for now. Now m renderer id, right? Let's talk about this for a little bit. So we know that OpenGL needs some kind of numeric ID. In this case, it's an unsigned integer that actually kind of keeps track of what. It's an ID basically for every type of object we allocate create in OpenGL, right? So if I create a texture, if I create a shader, if I create a vertex buffer, an index buffer, a vertex array, a frame buffer, whatever, it gets some kind of ID. And that ID is a unique ID that is an integer that identifies that specific buffer or that specific object that I've created. That's how it works. Now, I am calling this a renderer ID because other APIs also work on a similar system, right? So what I'm really doing here is just kind of keeping it fairly generic, even though this is an OpenGL series, so I am tying things very closely to OpenGL. You know, instead of just kind of calling this OpenGL ID or just ID or like, I don't know what I called it before, buffer or whatever, renderer ID is just the actual internal renderer ID. So if you're using OpenGL as your renderer, this is the numeric ID that is actually relevant to OpenGL, because we may have a high level kind of engine side ID that we also use for objects like that. All right. So yeah, just trying to explain what I'm doing here, because I'm not trying to kind of, this series is going to be kind of tough for me to do. Okay, now we're breaking like the fourth wall here. But anyway, this series is going to be kind of tough for me to do because I'm trying to teach you guys OpenGL, but also I'm trying to mix it in with how you'll likely be using OpenGL. And those are two different things, because if you look at any OpenGL tutorial, they just show you how OpenGL works. And that's great, but that doesn't tell you about how to use it in a game, or how to use it in an engine, or how to use it in the real world. I'm kind of trying to mix the two. I hope this makes sense. This is obviously a minor case, but as the series goes on, if you have any thoughts, just leave a comment below. I'm here, I'm human, I'm here to help you. I want to improve this series as much as you probably want to see it improved. So just leave your thoughts in the comments below. Anyway, let's get back to this, eh? So we have a render ID. I'm going to make a public constructor here. I'm going to take in const void pointer data, and then also an unsigned int size, okay? We're going to have a destructor here, and we're just going to have two functions, bind and unbind. I like to add these two. Now, of course, in an actual engine, you will have other things like set data, maybe have a lock and unlock mechanism so that you can actually kind of stream data to the vertex buffer as you're kind of rendering, because you, well, not as you're rendering, but before you render the next time, you might want to modify the vertex buffer, and so you might kind of lock it, modify it, unlock it, and do all that kind of stuff. There's a bunch of stuff you could do here. We're going to keep it simple for now. All we need to run our current program is bind and unbind. the series goes on and we start to kind of dive into more complicated topics and we start to require those features, we're going to just extend these classes. Okay, so bind and unbind looks pretty good, and we have a constructor and a destructor. Everything looks pretty good to me. So now let's go back to our CPP file. I'm actually going to go back to my header file, and because I'm using Visual Assist, I can just right-click on the class name, go to Quick Actions, and create method implementations, and it will ask me which ones I want, and I can hit OK. Now Visual Studio also does this. If you kind of hover your mouse over this and, I don't know, press the little arrow, you can also generate stuff, generate implementations for your methods as well. Okay, cool. So what are we doing here? If we go back to our application code, all we really need is if I copy these 3 lines, I'm going to put them back over here, right? We're going to include our renderer, because we need that, for these GL call macros, and then instead of buffer, it's going to be our renderer ID, and then instead of positions, it's going to be data, and instead of this thing, it's going to be size. And that's really all we need. Now I'm going to copy this bind buffer and put it into bind and unbind, except with unbind, I'm going to make it 0. Okay, pretty simple, pretty straightforward. One more thing we're going to add here is, of course, the deleting of this vertex buffer. So I'm just going to write GL call, GL delete buffers. We're going to delete 1 buffer, and it's going to be our renderer ID. Okay, that's it. That is our entire vertex buffer class. How simple is that? Now let's repeat the same thing for an index buffer. Now, because these classes are so similar, I'm actually just going to open this containing folder, and I'm going to literally copy and paste this vertex buffer, both of these files, the header file and the CPP file, and just rename them to index buffer, because that's how similar they are. Okay, back in Visual Studio, hit this little button here to refresh this. You can see we have 2 new files. Select both of them, right-click, include in project, and then let's start refactoring them. So this is an index buffer now. Render ID stays there. The only other thing we need is an actual count, because we need to know how many indices this actually has. Going to replace this with index buffer, of course, instead of vertex buffer. Const void data. Now, for now, we're going to support 32-bit indices. I don't know if it's even worth adding 16-bit indices at this point, especially in this series. Just know that obviously you can have different integer types, different integer sizes for your index buffer. You can have 16-bit integers, so like shorts, unsigned shorts. You can have 32-bit as well. We're just going to use 32-bit. I don't think there's a reason for us to support both, really. Of course, theoretically, there are performance benefits to using 16-bit integers if your 3D model that you're drawing isn't like that complex, doesn't have that many triangles, that it requires more than 65535 different, or 65536 different indices. But we're just going to keep it simple, unsigned int. So const unsigned int data. Now, because we've supplied an unsigned int and not a void, there's no point for us really just taking a byte size. What we instead want is the count. So how many indices have we supplied? Now, I like to distinguish these two by using the words size and count. When I write size, when I create a variable called size, that is almost always in bytes. If for some reason it's not, I'll definitely leave a comment or something, but like in the actual source code. But size means bytes, count means element count. So in other words, if I'm drawing the square, and I know that's 6 indices, right? 6 indices. That means if I write the number 6, that's the count, right? I don't write 6 times 4, which is 24. That would be the size. 24 is the size, 6 is the count, okay? And that's all we need here. Let's go back to this implementation file. Now I'm going to just hit Control-H over here to bring up this find and replace thing. I'm going to replace vertex buffer with index buffer, and then hit Alt-A to replace all in this file, make sure it's in current document, obviously. And there we go. So now I'll get rid of this and replace it with what I had there, which Visual Assist can help me out with again. And then finally, instead of size and data here, I'm going to write, instead of size primarily, it's going to be count times size of unsigned int. Now, there may be some danger here, because I'm obviously assuming that the size of an unsigned int is the same as GLUint, because I'm specifically not using that. Platform differences, I've never seen an unsigned int not be 4 bytes, to be honest. Yeah, like never. You might be on a platform where it's not, keep that in mind. I don't really like using the OpenGL one, so I'm still going to write unsigned int here, but just keep that in mind. You may want to even be really cautious at runtime and potentially check to see if the size of an unsigned int is actually equal to the size of a GLUint. Make sure you use the type, right? Not the actual, like, don't write GL unsigned int because that's not a type. Make sure you write GLUint. But you may want to be like really cautious with that, but anyway, I'm just going to use unsigned int. The other thing we need to replace is array buffer becomes element array buffer. That's really it. I mean, if I go down here, I'm just going to write bind buffer here to be element array buffer, and that's it. The other thing we obviously need to do is store this count somehow, so I'm going to write an initialize list here that just sets count to count, like that, up here. And then finally a getter, an inline unsigned int get count, const return and count. I'm actually also going to mark bind and unbind as const because they don't actually modify anything, and we'll probably want to call them on const objects in the future. Same for the vertex buffer as well. So vertex buffer, bind and unbind are becoming const. Okay, there we go. So that's it. That's really all there is to extracting those two. Let's go ahead and replace the code that we've got in the application.cpp file with this new these new classes that we've created. So back in application.cpp, I'm going to include both of them at the top here. So include vertex buffer and include index buffer. And then I'm going to scroll down here. And then when we actually create this vertex buffer, I'm just going to delete all this code